there, Math Rockstars. Let's take a look at rationalizing denominators. I've got 3 examples here, and I'll talk through each of the steps. For the first example, 4 divided by the square root of 7, to rationalize the denominator, we multiply top and bottom by the square root that we'd like to rationalize. So we have a square root of 7 in the denominator. And if I multiply the denominator by the square root of 7, I'll end up with the square root of 49 in the denominator. And in the square root of 49 is just plain old 7, so that will cancel out the square root of 7 in the denominator. But if I want to multiply the bottom of a fraction by something, I need to multiply the top of the fraction by the same quantity so I don't change the value of the fraction. So I'm also going to multiply the numerator by the square root of 7. So here we go. 4 times the square root of 7, that's my numerator. Square root of 7 times the square root of 7, that's the square root of 49. And then one more step. 4 times the square root of 7, that's all I can do in the top, but the square root of 49 is 7, and there's my answer. 4 times the square root of 7 divided by 7. If you prefer to write it as a fraction in front, you can write the answer as 4/7 times the square root of 7, but this funny looking thing here is very often what we end up using. It ends up being a bit more useful. All right, let's take a look at the next one. 10 divided by the square root of 2. I'm going to multiply the top and the bottom, numerator and denominator, by the square root that I'd like to have canceled out, that square root of 2. And then I'll clean this up a little bit. So I have 10 times the square root of 2 in the numerator. I want to remember that I can't multiply 10 times 2, right? 10 is a coefficient and 2 is the radicand, so I can't multiply them together. It's not the square root of 20. In the denominator, I have the square root of 2 times itself, which is just the square root of 4. And now I'll simplify this a bit. I've got 10 times the square root of 2 still on the top. Square root of 4 is 2 in the denominator. And then I'm going to take one last step and divide out a 2 from the numerator and from the denominator and end up with just 5 times the square root of 2 as my final answer. And then the last example I'm going to look at is a fraction underneath a square root sign. And if I'm simplifying, I don't want to have any fractions left under square roots. So I'll split up the fraction into the square root of 5 divided by the square root of 3. And that solves the problem having a fraction underneath the square root sign. But now I've got a square root in the denominator, so I'm going to rationalize, multiplying top and bottom by the square root of 3. Square root of 5 times the square root of 3 is the square root of 15. That's in the numerator. And then in the denominator, I have the square root of 3 times itself, which will be the square root of 9, and the square root of 9 is just. You can also think of this as square root of 3 squared.